There are places in this universe where the concept of solid ground no longer applies, where rock doesn't sit still, but flows like water, where iron doesn't rust, but rains from the sky in molten droplets, where atmospheres aren't made of air, but of vaporized stone and metal. These are the hell worlds. Planets so close to their stars that the laws of chemistry simply break down. Worlds where temperatures exceed the melting point of titanium, where day and night are separated by supersonic winds that tear the surface apart. This isn't about volcanoes or lava flows. This is about entire planets that exist in a permanent state of dissolution, where the ground beneath your feet wouldn't just burn you, it would evaporate you. In the next 10 minutes, we will descend into the most hostile planetary environments ever discovered. Worlds that make Venus look like a paradise. Worlds where survival isn't just impossible for life as we know it, it's impossible for matter as we know it. Let's begin with the hottest planet ever discovered, KELT 9b. This is a gas giant roughly 3 times the mass of Jupiter. It orbits a blue-white star so massive and so hot that the planet's dayside temperature reaches an unbelievable 4,300 degrees Celsius. To put that in perspective, that is hotter than most stars. It's hotter than 70% of all the red dwarf stars in our galaxy. At these temperatures, molecules cannot hold together. Water wouldn't just boil. It would disassociate into individual hydrogen and oxygen atoms. Even molecular hydrogen, the most common molecule in the universe, breaks apart. The atmosphere of KELT 9b is being stripped away in real time. The planet is losing mass at a rate of 10,000 tons per second. It is quite literally evaporating. Imagine that for a moment. Every second enough material to fill a small building is torn from the planet and scattered into space. The planet is bleeding to death. Astronomers estimate that in a few 100 million years, KELT 9b will be reduced to a naked core, a dense ball of heavy elements surrounded by nothing, but before it dies, it burns. The planet is so hot that it glows, not from reflected starlight, but from its own thermal radiation. If you could see it with your naked eye, it would shine red hot like a piece of iron pulled straight from a forge. This is a world in the final stages of thermal destruction, a planet being cooked alive by its own star. And it's not alone. WASP-76b is another ultra-hot Jupiter. On its day side, temperatures reach 2,400 degrees Celsius, hot enough to vaporize iron. The atmosphere here is a churning soup of metallic vapor. Iron, magnesium, sodium, all floating as gases in the superheated air. But the planet is tidally locked. One side always faces the star. The other side faces the endless dark of space. And on the night side, temperatures drop to a comparatively frigid 1,000 degrees. This temperature difference creates the most violent weather system imaginable. Supersonic winds, traveling at over 18,000 kilometers per hour, blast from the day side to the night side. They carry the vaporized iron with them, and as the winds cross into the cooler night side, the iron condenses. It rains not water, not acid, liquid iron. Imagine standing on the Terminator, the border between eternal day and eternal night. On one side a sky glowing white with heat, the horizon shimmering with vaporized metal. On the other a crimson storm, droplets of molten iron falling in slow, heavy sheets. Each drop would burn through anything it touched. Each gust of wind would strip flesh from bone. This is weather as a weapon, a planet-wide foundry where the atmosphere itself is made of molten metal. But there's something even more disturbing about these worlds. They are temporary. WESP-1b, for example, is being devoured by its star. The planet orbits so close that the star's gravity is pulling it apart. It's egg-shaped, stretched by tidal forces into an elongated ellipsoid. Its atmosphere isn't just hot, it's being funneled directly into the star. Every second WASP-12b loses 6 billion kilograms of mass. That's the equivalent of 100 blue whales, every single second. In just 10 million years, it will be completely consumed. It will vanish, swallowed whole by its own sun. This isn't a gradual fade into darkness. This is active destruction. A planet being eaten alive, in slow motion, over millions of years. And then there is HD 1899733b. This planet appears blue from space, a beautiful, almost Earth-like azure. But don't be fooled. That blue is not water. It is glass. The atmosphere contains silicate particles that scatter blue light, giving the planet its deceptive appearance. But the horror isn't the color, it's the wind. On HD 1899733b, winds reach 7,000 kilometers per hour, 7 times the speed of sound. And those winds carry with them clouds of silicate particles, tiny shards of glass suspended in the air, accelerated to lethal velocities. It rains glass sideways at hypersonic speeds. The temperature on the day side is over 1,000 degrees. The atmosphere is thick with vaporized sodium and clouds of molten silicate dust. If you were somehow placed on this world, you wouldn't die from heat alone. You would be sandblasted by glass, moving faster than bullets. Your body would be stripped down to bone in seconds. This is a planet that's beautiful from a distance, but up close, it is a nightmare. A cosmic blender wrapped in a veil of deceptive blue. Then there's 55 Cancri e, often called a diamond planet, because its core is likely made of compressed carbon. But this is no treasure world. The surface is a hellscape. Temperatures reach 2000 degrees Celsius. The entire day side is covered in a molten ocean of lava, not isolated lava flows. An ocean, a global sea of liquid rock, glowing red and orange under the light of its star. The planet is tidally locked, so the night side is cooler, but not by much. Even in the perpetual darkness, temperatures remain above 1000 degrees. The magma never fully solidifies. It forms a thin crust, but any shift in pressure cracks it open, releasing fresh molten rock from below. The planet breathes, inhaling heat from the star, exhaling it through volcanic fissures that cover the surface. And recent observations have revealed something even more unsettling. The planet's temperature fluctuates. For years, astronomers were baffled. A tidally locked planet should have a stable temperature profile, but 55 Cancri doesn't. The leading theory is that the planet has a thick, unstable atmosphere of carbon monoxide and hydrogen cyanide. This atmosphere acts like a blanket, trapping heat, but it is not stable. Massive volcanic eruptions periodically pump so much gas into the air that the atmosphere thickens dramatically. It blocks the starlight, and the surface cools slightly. Then, over time, the star's radiation burns away the excess gas, thinning the atmosphere, and the surface heats up again. The planet cycles between two states, shrouded in toxic clouds, or exposed to the full fury of its sun. It can't decide whether to suffocate or burn. These hell worlds force us to confront an uncomfortable truth. The universe is not built for us. It doesn't care about habitability. It doesn't care about balance or moderation. It builds extremes. Planets that evaporate. Planets that rain molten iron and glass. Planets covered in oceans of lava. Planets torn apart by gravity, and yet they endure. For now, KELT-9b will eventually be reduced to a bare core. WASP-12b will be swallowed. HD-189733b will continue to spin in its storm of glass for millions of years. 55 Cancri will breathe its toxic atmosphere until its star dies, but they are all doomed. These are worlds in their death throes, planets that exist only because the universe hasn't yet gotten around to erasing them. And one day, perhaps billions of years from now, another planet will take their place. Another world will drift too close to its star. Another atmosphere will turn to vapor. Another ocean will turn to lava. The cycle will continue, because the universe doesn't build paradises, it builds furnaces. And we are just fortunate enough to live far from the flames. For now, thank you for descending into the fire with us. Until next time, keep watching the dark.